I'm going to speak about the automatic takeoff and landing system we currently work on in a research project. It's a German-funded project. And within this project, we are developing also some image-based algorithms using machine learning and artificial intelligence. And I won't do a deep dive into the technology since the project is already quite far. So next year, in the beginning of next year, we are starting with test flights. But I will give you a brief overview about what's happening and where are the challenges now that arose from the project regarding how to deal with AI. So first of all, what we want to do is the automatization of the first and the last flight segment. So currently, we have an automatic flight for the IFR route, for a certain route before the takeoff, before the landing. And after this automatic guided route, we need to do a manual flight for the touchdown, for the approach. And for this situation, usually you have a straight line flying from the IFR route to the helipad. But since we also have to deal with some degraded vision environments such as fog or rain, we need to be aware of obstacles, some power lines, windmills, whatever, in order to calculate a trajectory that can be flown automatically. So what we need to do to achieve an automatic flight trajectory is to detect the helipad or the landing site. We also need to detect the position of obstacles and also need to classify them. And we need, of course, to calculate the optimal flight trajectory. And what comes out of this system needs to be handed over to the autopilot in order to fly it automatically. So within the system, we have mainly image-based applications, as I mentioned it before. So one application is the helipad detection, and the other thing is the obstacle detection. There we use cameras, and we are going to extend that with the next project by using IR and also LiDAR. So there we have the application, and as I mentioned before, we have some challenges now. So first of all, what we do in this project is not that we work alone. We have plenty of partners, and these are outside of the aerospace industry sometimes, not always. But since they are not directly working in the aerospace industry, especially if they are from universities, the partners are not aware of the regulation we have. So the sensors they deliver, they need to be tested in means of environmental tests, airworthiness standards, and so on. And we need our partners. We need the universities or other research organizations that work close to the state-of-the-art technology. And even in our research projects, we have an increase of regulation. So currently, software testing or testing in general is now oriented on a V model in most cases in the aerospace industry. And this is a mismatch with the rapid prototyping approach that plenty of different partners have. So we start now to increase the formalization on testing. So we ask our partners to deliver acceptance test descriptions, for instance, or procedures, as well as the reports. We formalize the documentation, so the partners are necessarily forced to create VDDs and COCs. But this is only applicable for the standard process we had in history, so to speak, so in the former projects. Now we have the problem that there's an unclear handling of randomized algorithms such as AI applications. And therefore, we need to develop our own formal process for research project. And also, we need to necessarily involve additional fields of research. We need to find an answer on how we are going to handle it with algorithmic bias. We need to explain why our algorithms are working, and we need to make use of systems like data visualizations. Now, these things are going to be regulated on EU level. Charles mentioned it before that the EU is working on the AI Act, and we need to be compliant to that, and this is also part of our research agenda. And the EASA is also working on guidelines to make it possible to get AI applications to a product. And therefore, they are in their guidelines. They have different classes of AI applications. So the first level is assistance to human. Can be split it into human augmentation, but also into the cognitive assistance of AI. And we know these applications. There are, for instance, image recognition, as I mentioned it before, is a typical application for that. On the next level, the application is about the teaming. And it is a cooperation and collaboration with the human. And also we know it from, at least from the media, that systems as ChatGPT evolved in the last years. And on the next level, the high advanced automation level, is that AI systems are proposed that provides mechanisms that are only overridable by human or are completely autonomous. And also here we have applications, and we also saw them already on the street, for instance. And all of these levels are applicable also in aerospace. And since the EASA does not classify it only, but also provides a roadmap where the guidelines for these different models are developed and released, we are having always a look on this timeline, so to speak. So when it was released in 2020, the first usable guidance for the second level was planned for 22. Now it was released in 2023. And we are waiting for the next usable guidance for the level 3 autonomy level in 2025. Based on these guidelines, also the EASA proposes a more formalized way of development. So we know all the V model that is quite typical in the aerospace industry, having different requirements on different levels on the left side, having the implementation on the bottom of the V, and have the test level on the right side of the V. For AI systems, we need to derive from the requirements the system has special AI system requirements. We need to align that with the data management and for the learning management. And then we can start with training. And then also the DLR proposes an idea of a W-shaped model that has a small peak in the middle for the learning process verification. And then we can implement the model. After the model, then it is directly aligned to the V model again. We need to test it. We have the inference model verification and integration, the independent data and learning verification, and the AI system requirement verification. What is important here is one more thing that is sometimes forgotten. In my experience in the last years, there is absolutely no first time right applying this model. And therefore, there's absolutely important to have a feedback between the system acceptance test and the system requirements. And if there is a mismatch, you need to go through all the system again. And this is something that is also applicable for the AI requirements. Okay. On the last slide, I want to mention one more thing. the company Dalian published this slide in the EASA days somewhere in the middle of this year. And they also are challenging the guidelines of the EASA, and they are also challenging the FAA. And they are already able to have a product, a machine learning product that has a supplemental type certificate. So they are already able to fly in the US with their machine learning application with a Del C certification. Okay, that's it from my side. Thank you very much.